We looked at how to graph inequalities, how to say inequalities, and how to write inequalities in Chapter 3, Section 1. In Chapter 3, Section 2, 3, and 4, we're going to look at how to solve inequalities. And so the first thing you need to know is there are a lot of similarities and there are some differences between solving equations and solving inequalities. The similarities are you still need to get the variable by itself. You still need to perform inverse operations to do that, and you still need to balance both sides of the inequality. What you do to one side of the inequality, you've got to do to the other. If it's x plus 5, you've got to subtract. That's your inverse operation. And you're done when your variable is by itself. But when you are done, you have more than one solution, more than one possible answer, one thing that's right that makes a statement true. You have lots of different symbols to keep track of, so you need to know what that actually means, that symbol represents. When you multiply, and this is a big one that we'll talk about later, but when you multiply both sides of an equation by a negative number or divide, the inequality sign flips. And last, the final answer, when you get down to x is less than whatever, it's not the solution. That number that you get is not always going to be the solution. It could be a solution, but it's not the final, that's it. It's the cutoff point between the solutions and the non-solutions. So if we look at this one-step inequality, it says solve. A number minus 3 is less than 5. What we need to do is know what the solutions to that are and what the non-solutions to that are. So we treat it like an equal sign. We're solving it like it's an equal sign. So we're adding 3 to both sides, getting rid of that 3, and so x is less than 8. This is your cutoff point. Solutions are one side, non-solutions are the other. So a solution would be 7, because 7 is less than 8. And the great thing about that is, back up here, a solution to this is also the same as a solution to this. 7 minus 3 is 4, which is less than 5. 7 is less than 8. 0 minus 3 is negative 3, which is less than 5. 0 is less than 8. So all the solutions to this are the same as the solutions to this, and vice versa. If you wanted to rewrite this, you could have it as 8 is greater than x. Because if this says x is less than, or what number is less than 8, this says 8 is greater than what number. It's asking the same question in two different ways. The three possible solutions are 0, negative 10, and 7. Three non-solutions are 8, 100, and 15. But there are an infinite amount of solutions, and there's an infinite amount of non-solutions in this case. So let's practice more. Solve m minus 6 is greater than negative 4 and list 3 solutions and non-solutions. Okay, let's do this one together. You got m minus 6 is greater than or equal to negative 4. What I need to do is I need to add 6 to both sides. And that's going to be m is greater than or greater than 2. 3 solutions would be 3, 4, and 5. 3 non-solutions would be 0, 1, and 2. Because 2 is not a solution to this inequality. I'm going to have to get a better board next time. This is dragging. So try this one. Solve. 12 is less than or equal to x minus 5. And there's 3 solutions and 3 non-solutions. Possible answers are x is less than or equal to 17, and solutions are 18, 19, and 20. Non-solutions are 0, 16, and 16.5. B is x is greater than or equal to 17, and the solutions are 18, 19, and 20, and non-solutions are 0, 16, and 16.5. C is x is greater than or equal to 17, and solutions are 0, 16, and 17, and non-solutions are 18, 19, and 20. D is x is less than or equal to 17, solutions are 0, 16, and 17, and non-solutions are 18, and 19, and 20. If you need more practice, that page 142, 4 through 18, and page 143, 24 through 38, every other even is where we want to go. Well, let's look at problems where there's fractions or negative values attached to the variable. For example, negative 2/3 n is less than or equal to 2. We need to get n by itself the same way as if it was an equal sign. We got to get rid of that negative 2/3, and you can do that by multiplying by the reciprocal. We'll multiply both sides by negative 3/2. I'm going to cancel out the negative 2/3 and get n by itself. Now, what happens again when we multiply both sides of an inequality by a negative? Or, I should also say, we divide. If you multiply or divide by a negative, what you have to do is flip the inequality sign. It was less than or equal to, now it's greater than or equal to. 2 times negative 3/2 is negative 3, so we have n is greater than negative 3. Basically, any number that's more than negative 3, or negative 3 itself, is a solution to this inequality. So 3 solutions, well, there's another way of writing that. N is greater than, or what number is greater than or equal to negative 3 is the same as negative 3 is less than or equal to what number. Solutions would be negative 3, negative 2, negative 1, because numbers to the right of negative 3 are those numbers. Non-solutions would be negative 3.1, negative 4, negative 15. There's lots more. So try this one. Solve. 6 is less than or equal to negative 3/5 w. Possible answers are w is greater than or equal to negative 10, w is at less than or equal to negative 18/5, w is less than or equal to negative 10, or w is greater than or equal to negative 18/5. Look for more problems on page 149, numbers 2 through 28, every other even. So practice, if you have a partner, practice with a partner. If you don't have a partner, obviously you might be doing this on your own. Try to do the best you can on this and compare your answers. I'll do the problems together real quick with you, but my handwriting might be a little bit ugly. Go ahead and pause it now and try to do these two problems. Okay. Again, remember to pause it right now, or I'm going to go forward and solve these for you. When we're working with these types of problems, you see a number on the outside of the parenthesis. That should tell you that you need to distribute. So you're going to distribute the negative 3 to both the 4 and the m. You're going to distribute the 4 to the 2m and the 1. Negative 3 times 4 is negative 12, minus negative 3 times m, which is negative 3m. It's greater than or equal to 4 times 2m is 8m, plus 4 times 1 is 4. I have an equation with variables on both sides. Simplify that. Add the opposite. Now I get the variables on the same side. I'm going to subtract 3m from this side. I'm going to subtract 3m from this side. I'm going to have negative 12 is greater than or equal to 5m plus 4. Subtract 4 from this side. Subtract 4 from this side. I got 5m. And I got negative 16. Finally, in order to solve this, I'm going to divide each side by 5. Divide by 5. M is alone. I have the greater than or equal to sign. Negative 16/5 is simplified. My answer is negative 16/5. I wanted to rewrite that so that my variables on the left side would have m is less than or equal to negative 16/5. Because you have negative 16/5 is greater than or equal to m, it's the same thing as m is less than or equal to negative 16/5. Next problem, I have a lot of stuff going on, but the main thing is I have a distributive property to simplify. 2t plus 2 becomes 2t plus 4 because I distribute the 2 to the t and the 2. Bring the 3t down, bring the greater than or equal to sign and the 1, and then combine like terms. 2t minus 3t is negative 1t, plus 4 is greater than or equal to negative 1. Subtract by 4, subtract 4. Negative 1t is greater than or equal to negative 5. So t is less than or equal to 5 because I would be dividing by negative 1 on both sides. When you divide or multiply by a negative, you flip the inequality. T is greater than less than or equal to 5. M is less than or equal to negative 16/5. Try this one. Negative 6 times the quantity x minus 4 is greater than or equal to 7 times the quantity 2x minus 3. Possible answers are x is greater than or equal to 2 1/4, x is greater than or equal to negative 3/20, x is less than or equal to 2 1/4, or x is less than or equal to negative 3/20. please pause and try to do that now. Alright, for more problems like that, you want to do page 156, numbers 13 through 39, every other odd. Good luck.